Today we are going to start with the applications of refraction at curved surface. This is the application on refraction at curved surface. We are discussing different cases in that. Okay, clear? We reduced 16 cases into 8 by law of reciprocity, and the 8 cases to 4 cases by real and virtual analogy. Those 4 cases we have discussed. In all the 4 cases we have got same relation, that is a uniform relation, that is mu2 upon v plus you see mu2 upon v plus mu1 upon u is equals mu2 minus mu1 upon r. Okay, this is the situation we got. So generally in books you will see mu2 upon v minus mu1 upon u is equals mu2 minus mu1 upon r. That is with respect to Cartesian coordinate convention. Cartesian convention, that is. This is a real space and virtual space convention what we are using. Don't get confused with that. Okay, clear? Compatibility of problem solving will be good with this real space and virtual space convention. Okay. Now let us go with this application. A hollow sphere of glass as shown in the figure 3.9 of refractive index neta has a small mark on its interior surface, okay, which is observed from a point outside the sphere. This is the interior mark, it is, okay. This is air and outside also air, okay, clear. The thickness of this sphere is what? Glass sphere, how much? R. How much? R. You see, from this is a center, from center to this peripheral is this outer surface is, what is the distance from center to outer surface? 2r, because diameter is 4r. From here to here 2r. From here to inner surface r. 2r minus r is thickness. Thickness is r. So as you see, a hollow sphere of a glass as shown in the figure 3.9 of refractive index theta has a small mark on its interior surface which is observed from a point outside the sphere on the side opposite the center. Means this is center, side opposite to center is this. So here is the observer. This is the, here is the observer. Okay. The inner cavity is concentric with the external surfaces. External surface. The inner cavity is concentric with external surface. External surface is what? Spherical surface. It has center here now, and inner cavity also having same center or different center? Same center. That's why they are saying concentric. Okay, clear. With the external surface, and thickness of glass is everywhere equal to the radius of the inner surface. I just concluded that the thickness is r. Prove that the mark will appear nearer than it really is by a distance neta minus 1 upon 3 neta minus 1 times r, where r is the radius of the inner surface. So this is the situation he is explaining. You see this is the center, this is the outer surface. The distance is 2r from center to this r. So the thickness is what? R, thickness of the glass. And observer is in this zone. Observer is in this zone. Okay, got the point? Is it clear or not? Inside air and outside also air. Its refractive index is what? Neta. So this is real object or virtual object? A mark is placed, a real material object it is. Real object. Okay, what happens to this? Let us see once. Okay, let us go with the question. Now let us go. Let us draw this ray diagram for this given question. Okay, first of all. Okay. Now, he gave this as how much? 2r. This has how much? 4r. This is 4r. From external surface is 4R. What is this? 2R. Right? Got the point. Now this is a object here. What is placed here? Object. O. Where is the observer? This is the center, opposite to the center. Here is the observer. Observer. Here is the observer. Okay. Now, what happens? The rays. Okay. The ray starts here. First of all, I will take one ray as a standard ray. It is going like this. It will go deviated or undeviated? Deviated. Because at this interface, this is a air nana. This is air inside. Okay, this is neta. Again, this is air outside. Clear? The ray which is starting at the object. Okay, it is first falling on the interface between air and this medium. Okay, it is going undeviated because at this point, if you draw a normal, what happens? Yes, it is traveling along the normal or not? Yes, and it is getting incident at this location also. At this location also, this is normal now. So it will go undeviated. Okay, this is the first thing. Now, next. This is a incident ray from the object, and this is a point of incidence. At the point of incidence, you are supposed to draw normal. Okay, this is the normal. Okay, if there is no medium change, the ray is supposed to go in which direction? Like this. It is supposed to go in this direction. Is it clear or not? But it is denser compared to this, so it will move towards the normal or away from the normal? Towards the normal. It will go like this. Means, if observer is in this medium, what he will see? The refracted ray. This is the surface now. Yes, this is the interface between this medium and this medium. If I place observer in this medium, what he feel? Yes, the refracted ray 1 and refracted ray 1, 2 are coming from which location? You extend it back. This is O1. What nana? O1. Means if I place observer in this medium, what he feels? This ray and this ray are coming from this location, O1. Yes or no? Yes, you see, I will extend it back. Clear? This is a dotted line. Okay? So now what happens? It is incident at this interface. This is the interface between air and medium again. Okay? At this point you are supposed to draw what, Nana? Normal. You are supposed to draw normal. Okay? So normal, I am extending the normal from here. Okay? Clear? Okay, this is the normal at this point of instance. It is supposed to move like this actually, but it will move away from the normal or towards the normal? Away from the normal, like this. If you extend it back, what you are going to get? Away from the normal. It is moving away from the normal, like this. If you extend it back, where it is going to meet? Here. This is O2. What, Nana? O2. Means, if the observer is here, what he feels? One ray is coming like this, one ray is coming from O2. Means what happens? What is his final feeling of this observer in air? Yes, this object is located here, but he is seeing here. Means there is a shift now. Yes, that shift he is asking to prove. What he is asking to prove the shift as? Neta minus 1. Neta minus 1 upon 3 neta minus 1 times R. Okay, got the point? You understood the ray diagram here? Is it clear or not? So that is a simple situation. First of all, we should apply what relation here? Mu2 by V plus mu1 upon U is equals to mu2 minus mu1 upon R. Okay? How many times I should apply this relation here? 2 times. Because refraction is taking place at two interfaces. At first this interface the refraction is taking place, and at this interface also refraction is taking place. First I should apply this relation at this interface 1, at this interface 2. Clear. Finally I should get the location of O2, and he's asking shift. Shift means what? O2. O2. Okay, I will name it as some point A here. Yes, point A, and this is O. Clear? Right. Now I will name it as some point B. No problem. I can name the points. I can name this as some point D. Okay, if you want, you can name it. No problem. Right. Now coming to the point here, I shall go with the solvation of this. Now you understood the ray diagram? Sure. Is it clear or not? Ray diagram is very important. From this only we should get conclusions how to go with the question. Okay, right? Now, at the first interface, what we are going to get? At the first interface, please. This is mu1, this is mu2. Got the point? For the first interface, this is mu2, this is mu1. Can you say what is mu2? Neta. Mu1, 1. Right? What is a real space? This is real space for this interface. This is what? Real space. This is virtual space. And the object is real. For this interface, what is the object? This. What is the distance? OA. OA is what? Object distance. What? 2R. So object is real means we will take object distance positive. So object distance for this interface 1 is 2R. OA. That is 2R. So this is the pole for the first interface. A is the pole for the first interface. For second interface, what is the pole? B. Okay, that's why I'm naming. Okay. Now, can I write the relation now? Any problem? Can I write? Yeah, mu2 is nothing but neta. Yes. Image where it forms we don't know. Let us substitute it as V. Otherwise V1. What Nana? V1. Because it is interface 1. Okay. Mu2 neta upon V1. Mu1 is what? 1 upon U 2R plus or minus? Plus with sign convention. Plus 2R. Next, mu2 minus mu1 means what? Neta minus 1. What is the radius of curvature? What is this? R. Positive or negative? Negative. Why beta? This is virtual space. Okay, please. Okay. Now, you see, I am taking neta minus 1 upon the radius of curvature of this interface is R. Clear. This radius of curvature is in real space or virtual space? It is in virtual space. It is in virtual space. Okay, so we should take this as negative. Okay, can I? Sure? Right, let us go for that. Neta upon V1 plus 1 upon plus 2R plus 2R. Object is real. Neta minus 1 upon minus R. Minus R. So on solving, what you are going to get this? Neta upon V1 is equals, you take this side, minus 1 upon R. Okay? Clear. I will take this term this side and I will take minus 1 upon R as common. Neta minus 1 plus 1 upon 2. Got the point? So V1 is nothing but minus 2 neta R. Okay, 2 neta minus 1. You got it or not? I solve this and I make V1 as a subject. Any doubt in this? And minus 1 by 2. 2 neta minus 1 upon 2R. So I make V1 as the subject. For the point, you solve for V1. A simple mathematics. Okay? Right. This is V1. Now we are supposed to calculate what? Second interface. What interface beta? Second interface. At second interface, what is going to happen? Let us see first. Second interface. Okay? What is this V1? Can you say? V1 is nothing but AO1. What a? AO1. This V1 is nothing but AO1. So V1 is nothing but AO1. Clear? And this O1 is what now? Object for the second interface. Yes or no? This rays, this incident ray is appearing. This and these are the incident rays now. For which? For interface 2. this ray and this ray are appearing to come from what? Over. So incident rays are appearing to come from over, but they are diverging or converging? Diverging. So for the interface 2, O1 will be the object because these incident rays are coming from O1. Clear? So object is always related to incident rays, I say. Okay? And these two incident rays are converging or diverging in nature. Diverging. So for interface 2, O1 is the object, that too real object. What object? Real object. And this is the virtual space, this is the real space. Why this is the real space? Refracted rays in this space. What's the point now? What is the pole for the second interface? B. Now you are able to understand. Can I apply that? Yes, sure. So what is the mu2 for the second interface? 1. Mu1 is neta. Okay? Clear. What is object distance for this second interface? V1. What the name? V1. From here to here. V1 plus, V1 plus R. This is V1. AO1. What is object distance for second interface? BO1. What nana? BO1. BO1 is nothing but AB plus AO1. AO1 is what? V1. V1 plus R. So for that we are supposed to calculate V1 plus R. Let us calculate V1 plus R. Sure? Right. V1 plus R. Can you say what is V1 here? Minus. Don't take minus better. Why we should not take minus? Because? Why we should not take minus? Can you say? It just is a sign convention. This is a sign convention. It shows that, okay, image is formed in virtual space for first interface. So 2 neta upon 2 neta minus 1 plus R. So then what we are going to get here? Please.
R into 1 minus 4.
How much?
R into 1 minus 4.
4 neta minus 1 upon 2 neta minus 1. Sure. R I am taking it as common. Okay? R I am taking it as common. 2 neta minus 1 plus 2 neta. What is that? 4 neta minus 1 upon 2 neta minus 1 times R. Is it clear? This is what better? This is what? Object distance. For what? Second interface. Okay? For second interface, this is the object distance. Means what? U2. What nana? U2. Right. So for the second interface, I am writing a relation that mu2 is nothing but for second interface. For second interface, mu2 is what? 1. This is the second interface. This is mu2, this is mu1. 1 upon V2. We don't know image distance. Okay? Plus mu1 means what? Neta. Upon object distance is what? R times 4 neta minus 1 upon 2 neta minus 1. So what I should write here? R times 4 neta minus 1 upon 2 neta minus 1. 2 neta minus 1. Okay? Is equals mu2 minus mu1. Mu2 minus mu1. How much? 1 minus neta times. What is the radius of curvature of this? From center to this is? R plus R, 2R. Okay? Clear. So radius of curvature positive or negative? Negative. Because this is real space, this is virtual space. 2R is lying in virtual space. So I will take minus 2R. Okay? Now we are supposed to calculate V2. Sure? Yes. How to calculate V2? 1 by V2 is equals what है? Minus 1 by R common लेते क्या नहीं करते? Yes? 1 minus neta upon 2. If you take this side, what you will get? Plus neta into 2 neta minus 1 upon 4 neta minus 1. You are able to get the point. I am shifting this term this side and I am taking minus 1 upon R common. Is it clear or not? So what you are going to get here? Minus 1 upon R times 4 neta square will get cancelled. What you are going to get then? Yes, 4 neta minus 1. Yes, plus neta plus neta plus 2 neta. Plus or minus, this is minus 2 neta upon 2 times 4 neta minus 1. This is the calculation I did. Okay, this is 1 by V2. From this V2 what we can understand? Can you say? 2 of minus of 2R. What Nana? 2R. 2R 4 neta minus 1 upon how much? 3 neta minus 1. So what is this? This is what? Image distance. In which case? Second case. Means this is the distance of what? In the second interface, where is the image? O2. So what is this distance? BO2. BO2 is what? That is the image distance in second case. In question what is asking to find? Shift means OO2. What Nana? OO2. I can write OO2 as BO minus BO2. Sure? So shift is nothing but here. This V2 is nothing but here. V2 is nothing but, that is what? BO2. BO2. BO2 is equal to how much we got? 4 neta minus 1 upon 3 neta minus 1 times 2R. Okay? Clear? You are able to understand? BO2. We got BO2 as this. Okay? The magnitude I am taking. That's all. BO2. BO2. I need what? Shift. What better? Shift. Shift is nothing but BO minus BO2. Very good. What is BO better? BO is what? 3R. 3R minus 4 neta minus 1 upon 3 neta minus 1 times 2R. Good. So R counter लेने से क्या निकलते? 3 minus means 9 neta minus 3 minus 4 neta. Sorry, 8 neta na? Yeah, 8 neta. This is 8 neta. 8 neta minus plus 2. 8 neta plus 2 upon 3 neta minus 1. So what we are going to get here are 9 neta minus 8 neta is neta minus 1 upon 3 neta minus 1. So this is what shift means. It appears this much closer. Actually, once please come to the projector. I can explain it clearly. You see. Now, here, this mark is here. For this observer, it appeared to be shifted from here to some front. It came forward, it appears. Actually, the real position of this mark is here, but what observer feels, the mark is here. Okay, that is a situation. Okay, beta? Is it clear or not? Now, let us go for this. Finally, what conclusion we got? He is asking to prove this is the shift. This is the shift. We proved it, yes? We proved the shift or not? Sure. Clear. We observe carefully. Here is the object. Okay. Here is the observer. Okay. Clear. Finally, this observer felt what? Here object is at O2. What Nana? O2. What is the shift? O2. So we found O2 now. Yes, O2 is nothing but BO minus BO2. BO2 is nothing but image distance for what? Second interface.